So I'll start out with a look at the threat trends and the attack advancements, kind of give us a perspective on history, how we got here, what we're doing right now, our traditional security infrastructures, and what the protection models look like today, kind of where we are, state of the market. And then I'll discuss why state of the market doesn't work and why those security architectures fail. We'll look at the false sense of security we get from penetration testing and all of our security assessments. There's a constant effort to go out and grind on the architecture we've got to make sure it's tight, make sure it's secure. But the problem is that's really a false sense of security. It doesn't really help the issue because there's a big difference between testers and hackers. Then we'll get into the meat of the presentation, looking at what good analytics can be with flow statistics, some fairly easy things to do, a little bit more advanced look at how that can be leveraged, and then better analytics using PCAP or packet capture, and then fun with steganography. There's some cool things you can do to look for compromises and detect compromises using steganography. I'll look at how we turn all of that detection process into a real prevention strategy. And then I'll summarize by looking at how to leverage the power of the network. At the end of the day, the thing I want to keep in mind is if I don't leave your environment with the data on this, or thumb drive, it probably went across your network. So you've got an extremely powerful tool in order to see that, that compromise and also prevent it and capture it. So in terms of the threat trends, do these work? Is there a way to turn these on? In terms of threat trends, it used to be that people wanted to get in quickly, get as much data as they could quickly, get back out of your environment, but that's changed now. Really what the bad guys want to do is get in very stealthily, stay in, and steal quietly from you for years and years to come. This one's on? Yep. Is that better? Ah, good. I'm not trapped behind this podium anymore. And steal quietly from you for years to come. That means they're using things like rootkits. But the first thing I want to point out is every rootkit is not an APT. All APTs are not really APTs. The reason most of us in the security business hate that phrase is because it's so overused. I would actually call it advanced persistent marketing. What really is APT is almost exclusively state-sponsored. So look at the term, advanced. It's very advanced. They spend a lot of money developing it. It's persistent. It's designed to stay in the environment for some number of years. As far as O-Day attacks, I look at that as kind of submarine warfare indeed, and the hunt for Red O-Day. You know they're out there. There's plenty of them out there. But the first time you're going to actually know about that zero-day attack is the time that you feel the effects from its attack. Right, so we have to look at different ways to be able to detect that. The attackers now are highly motivated. They're willing to make a capital investment. They're willing to spend a significant amount of money building code just to go after your environment if they think that you have something they want. There's a proliferation of comprehensive toolkits. In the DDoS market, this is really appalling right now. There's kits out there now that I can use to launch a DDoS attack against a site, knock it completely offline, and if they happen to come back up fairly quickly, they've got some protection scheme. I can just change the nature of the attack within minutes with a couple of clicks of the mouse and bring them back down again. And do this with different types of attacks, volumetric or going after the back-end database servers. Same thing for malware. There's a site that I was at recently in China. You can take your malware, upload it to their site, they'll send you back a repackaged version of it with a list of antiviruses that won't detect it. And they have guarantees around this. And if you can't figure out how to use their site, they have a 1-800 support number to walk you through it. What's the point of all this? Well, they share their attacks way better than we share our defenses. If you have any doubt about this, go out first weekend in August to Vegas and attend DEF CON. 10,000 people there, about half of them are hackers sharing their exploit code. The other thing we need to do is really start looking at understanding the value proposition for the criminal. And this is why so many people spend $100,000 to protect $5,000 assets, and likewise spend $5,000 to protect multi-million-dollar assets. We have to understand what they're after. What do they see as value? And it may not just be those credit cards. It may be that you're doing something that is contrary to their political beliefs. So there's a lot of different ways they can see this value, from monetary to activism. We also need to look beyond the criminal mind at state sponsorship. What are they after? Do you have research projects going on? Well, I would say so probably here. Are you part of critical infrastructure? Are you looking to drive a program that's going to change a way a business is done that will result in a large degree of product or capital inflows? So what are they looking for? What's the political motivation? Have you been seen as being on the side of some political dissident group within that country? That could set you up as a target. So the traditional infrastructures and models, or as I thought, how do we get to spend so much money? Well, first we started out with protecting the perimeter against attacks, and we were just looking at firewalls up here, intrusion prevention systems, and then we started protecting the network itself against DDoS attacks. And then came the idea that, well, we've got to look at user systems, so antivirus, anti-malware, host intrusion prevention, you know, all that stuff that slows your system down to a crawl. It's all layered up with it. Then protecting the filters, more filters. We had to filter web, email, files, content out to the internet. That was the start of DLP, all of those filters. Now there are dedicated tools made for data loss prevention. So there's now a large number of those tools. They're implemented throughout the network. And then we have to protect our web servers, which we're not doing a good job on, because after 10 years, the #1 exploit against web servers, still SQL injection. If you look at things like the data breach investigation report, it shows that some 60% of server attacks still involve that because we're not fixing the problem. So we get into the protect everything model. What does that look like? Well, we have all the things we've talked about with the host area, file integrity checking, antiviruses, IPS, and then we do identity checking, 2-factor, 3-factor, 4-factor. Okay, no, that's not true. It's actually fairly uncommon to see 2-factor authentication because that little RSA token can cost $35 to $65 per user, and you get into a large environment with 10,000 users, that can get pretty pricey. But then we have all of our layers of firewalls and IPSs at the perimeter, internal, in different places, and all of our filtering technologies and DDoS protection on the outside. We want to make sure it all works, so we do application testing of this area. We do vulnerability testing inside here and penetration testing from the outside. I used to be a penetration tester, and let me tell you, it's incredibly easy. Of course, I cheated. I would take a set of CDs, maybe 5 of them, label them funny dog videos, and drop them in the parking lot. 3 out of 5 of them would end up in a user system. Guaranteed it would compromise the system, and I win, game over. But it's incredibly easy to do. So the state of the market protection model. This is really where we are today. And I took a few things out of this slide from my previous employer as appropriate. But at the end of the day, we've got firewalls, WAFs, web application firewalls, and we even do testing against the servers and put real-time information back into here. Syslog, who logged into this system? What did they do? What files did they access? When did they do it? We have all of our endpoint antivirus all flowing back in. Everything flows back into our SIM for analysis and correlation. And the idea here being that if I say, this guy touched the firewall, but we didn't let him in, we stopped it. Later on, I see him over here. He got caught by an IPS system, but we caught him again. Still goodness. Later on, I see him trying to log into this server over here, and I see he failed 3 or 4 or 5 times. But then after that, I see that this server's admin account changed password. And now there's a new account over there. And if I have the SIM, it's easy to string all these pieces together, and I can figure out that badness happened. However, at the end of the day, there's still a big gap in this, and here's why it fails. There's primarily 2 reasons why our security infrastructures fail. First one, software. guy from Cisco was up here saying that one of his coworkers spent a couple of weeks developing 200 lines of code. Well, I used to be a programmer. I don't know any time I developed 200 lines of code, and it worked first time. Perfectly, did exactly what I expected it to do. So it's developed by people. It's not perfect. And when you amplify that and say, 200 lines of code, 2,000, 10,000, hundreds of thousands of lines of code. Typical applications these days, large applications, you're talking tens of thousands of lines of code, an operating system, something complex with all its utilities, millions of lines of code. I guarantee there are security flaws in there. The other big reason? People. Coincidentally, also developed by humans and not perfect. This is why social engineering works. Classic case. I was doing an investigation with a company where the CIO's system was compromised. Every time he took his computer home, it phoned home and sent corporate information out to the internet. We tracked it back. The source of this infection came from his admin assistant. Her system had been compromised. It took a little while to figure this one out. But when I started checking the email archives, I found that she had reached out to the quarantine and pulled over an email out of quarantine. Now, this email said, the following email has been quarantined. Email, FedEx, your delivery. Reason, contains a virus or malware link. So I asked her, why did you open this? She said, well, I wanted to find out what I was getting. I said, did you not notice that it said it was virus? She goes, oh, well, it's from FedEx. I figured the system made a mistake. I said, well, did you order anything that was supposed to be coming from FedEx? Well, no, but I thought maybe I'd forgotten or something. Again, social engineering works. That's why they have that T-shirt that says social engineering. On the back it says, because there's no patch for human stupidity. So why can't we make it more secure through testing? Well, first off, the whole concept of testing, especially in application testing, is I want to see if it does what I thought it would do. I'm not testing to see if it does something that I never anticipated it to do. So I'm testing to see if it does the thing I wanted it to do, not trying to break it. I had this saying on my Twitter account. It says, an engineer looks for, how can I create something to fix a problem? A security engineer says, what happens when that breaks? A hacker says, how can I break it to my advantage? Okay? Another thing, vulnerability and pen testers, they don't usually build custom code to attack your environment. Hacker will. They've got a limited amount of time. They've got their toolkit. That's what they're going to use to go after you. A hacker will build whatever he needs to do to get into your environment. Vulnerability assessors and pen testers don't have the same motivation. The pen tester, he gets paid whether he breaks in or not, right? So he tests it. It's got a couple of weeks. He says, no, couldn't get in. You're all good. You're happy. He's happy. He gets paid. Everybody's good. On the other hand, if he breaks in, you've got something to fix. You're not quite as happy, but you know you've got to go fix something now. On the other hand, a hacker does not have those same time bounds. He can work on this as long as he needs to. Also, pen testers, they care about breaking your stuff, right? They're not going to blow up a system. They care about collateral damage. It's going to be a bad thing on the contract. You might not renew. A hacker doesn't care. He blows up a system, he backs off for a while, comes at it again with a different technique. And lastly, pen testers and vulnerability assessors don't have years to work on you. A dedicated hacker, especially somebody sponsored by a state organization who knows that you're doing research on something that's going to change the future of some business, and they want that, they're going to keep poking for months, years to try and find the weak spot to get in. You're doing okay. So what can we do with analytics? Well, some of the first things we can do, we can look at NetFlow, JFlow, CFlow, and we can put it into some very basic analytics engines, and we'll catch the obvious stuff, like why is 80% of your traffic iTunes? I used to do these types of analysis for major corporations. I'd come back and say, well, 80% of your traffic is iTunes. The most popular place your users go to is Facebook. They'd say, well, we block all of that. But the packets say differently. It says you're not blocking all of this. Another thing, why are you running a game server on the campus net? The case where investigating for the Navy, and every time they were in dock, everything was fine on the network. They go out to sea, that satellite connection was just absolutely hammered. Well, that's because somebody was running a porn server on the ship, and it was chewing up the bandwidth big time. You can also catch the somewhat less obvious things, like, so who do you know in Cuba? Why are you talking to them? Unexpected or banned protocols. Most people don't run FTP in a corporate environment. And yet, if I do these types of analysis, I'll find FTP protocol out there. Encrypted channels. Do you have a partner in Belarus? Now, those same people who are saying that, I pointed out to them that 80% of their traffic was iTunes and that the #1 place they go to is Facebook. I also said, do you have a partner in Pakistan? They said, oh, no, we fired those guys years ago. So why do you still have a VPN to them? We don't have a VPN to them. I said, well, this says there's IceCamp packets and ESP packets going over there. That would be a VPN. 3 guys got up and walked out of the room immediately. With a little more work and a little more storage, you can start catching real outliers. Like, why does that system send more stuff to the internet than he receives, and only at 3 o'clock in the morning on a Wednesday? That seems a little suspicious to me. So all the rare stuff. Also, new connections. Why are you acting differently now? These servers over here, they've never talked to any of these addresses, and yet now they're doing it on a regular basis. What's up? Did you fire up a new application? This is grounds to go talk to the people that own those servers and ask them what they're doing differently. And you'll want to start comparing these real-time streams with the historic norms. This is kind of like what SourceFire RNA does. It builds a map, but you can do this too, is what I'm advocating. You can build a map of who talks to who, and then start looking for something different. Some more advanced stuff. This will require one-to-one capture, but some of the potential triggers and fingerprinting you can find, and this is one of the things we're doing over at level 3, since we own better than 50% of the internet backbone. We see a lot of this traffic and get a lot of opportunity with over 1 million different NetFlow sensors. But what we found is that you can look at the packet size within a sequence and start figuring out when malware is being downloaded or distributed. Also, I can look at the conversation timing. You send out a packet, 8 seconds later you get this packet back that's this size, 6 seconds later you send this, and then 8 seconds later you get 14 packets of this size. That I can tell that's a malware download because we have the history to back that up, and we can see the way that the person's cut their code up into those size pieces in order to make it pass by the IPS and antivirus systems. So also flags and window size. These will be indicators for the type of system you're talking to, as well as potentially the type of malware that's being downloaded. Some of the things you're going to have to do one, set up a honeypot, tar pits, trying to attract the bad guys so that they send you their bad stuff, start trying to talk to you. Lots of post-attack correlation to try and figure out what they did and identify that threat. Investigate those suspicious sequences to see if they're really potential attacks. Reverse engineer the stuff that you captured to see what it was trying to do. And then you can look for similar things. You'll also want to build a malicious IP watch list of high-risk traffic, and then take that watch list and link it to your external firewall so that you stop talking to those people. If you know who the phone home guys are, who the bad guys are out there, the botnet controllers, malware distribution sites, don't let your people talk to them. A little bit more advanced stuff, and this is real bleeding edge, and actually this is what the antivirus and IPS companies do. They do payload capture and analytic modeling. Yes, some assembly required. You'll have to put those frames back together and put the actual code back together. Some of the potential triggers and fingerprinting, again, the size of the malware payload once you've reassembled it. Executable code and scripts. Is somebody embedding executable code and script into a web load? Kind of suspicious there. And then application and port targets. If I see some code coming across and it's got references in it to an Oracle application or a SQL application, well, that's pretty bloody suspicious, because why would they need to download that to your system unless they were going to then use you to go attack that Oracle or SQL application? What are the steps involved? Well, they're the same steps for the last section, only it's going to be a little bit more in detail. An oversimplified architecture example. The first thing you've got to do is capture the data for flow and PCAP sources, run it into some type of parser, it could be Perl, Ruby, whatever. Then you're going to do flow reconstruction for the JFlow data or NetFlow data and message reassembly for the packet captures. You can put that into some type of standard format. That could be syslog. Syslog will be easy for the file-based connectors because you still want to send your NetFlow information over to your SIM, but then you'll want to send the rest of it through, let's say, potentially a Flume agent to Apache Flume and into your Hadoop cluster. You'll have a reservoir of research data that you've already collected, and you can run your analytics comparing this to your research data and produce your reports. This will give you a target or a hunt list of where the badness might be so that you can go look for it. Still doing all right. Stego, this is a cool use of your old IPS boxes, which really don't do what they were intended to do because everybody's writing custom malware now that blows right past that IPS box. But what it can do is look for stuff that you told it to look for. So one of the ideas I had some years ago is I'll set up a trap. I can use any one of these Stego tools. There's hundreds of them on the market. But essentially, I can pick multiple locations of increasing sensitivity, maybe in the web server, someplace that a guy could get to if all he did was a little URL manipulation, and he could get to this spot in the web server. Not hard. Again, a little bit further in your network, a place that's harder to get to, where they'd have to have permissions to get to that server, create a second level of security awareness and compromise detection. And then where the crown jewels are, I create another file. Easy way to do this, take these labels here, make them an image, use Stego to put a message in there, a custom message in there, then write an IPS signature to look for it and see if it's going out the door. Also see where it's moving around internal to your network because, yes, I recognize the obvious issue with encrypted channels, and it's probably, by the time it actually leaves your network, it's probably encrypted and you may not see it. When it's moving around inside your network, you have a good chance of catching it till it gets to the place where it's going to be extricated from. But again, you can also put digital watermarks on these files. Label them something like merger and acquisition strategy for this year. I guarantee somebody's going after that one. The nice thing is, when you digitally watermark these things in a sophisticated manner, they're good evidence in court. So when you finally do catch this person, they're going to jail for it. So again, there's a lot of tools you can use there for that. So turning all of this into a real prevention strategy. Okay, all BS aside, this is going to take some work and investment. It's not going to be cheap. It's not going to be easy. Building the analytics engines and developing the tuning skills just to get a minimum level of competency. Although here in this environment, I guess I'm probably speaking more from corporate environment. Here in your environment, I'll bet you've got a lot of people that are really, really good with writing Hadoop analytics, working with big data, and writing these types of algorithms. So your come up to speed time may be less. Building the monitoring infrastructure will take at least 2 to 6 months, depending on the complexity of the environment. The database of signatures, once you start attracting the bad guys in so that you can start building your heuristic models and getting your reservoir of this is what badness looks like, this is malware that I've been able to capture, probably another 6 months. And building the reverse engineering library, 8 to 12 months, depending on the talent of your security programmers. But some of the things you also want to ask yourself, when should encrypted channels be used? I talk to a lot of companies. I ask them, well, do you restrict encrypted channels going out the door? Well, no. Why would we? Well, if there's an encrypted channel going out the door to Iran, wouldn't you think that's a maybe tiny bit suspicious? Now, granted, in a research environment, a university environment, you're probably talking to a lot more people, and you may want to encrypt that data. But if it's going out to certain potential enemy states, maybe that's your research data leaking out the door. You want to look at who do we talk to encrypted and why and when is it appropriate. Here's another thing. When knowing can hurt you, there's a liability that comes with knowledge. If you know that there's a break, if you know something's broken and you don't do anything about it, then you are more culpable at that point. You have to own up to that responsibility of knowing something's wrong and knowing you're going to have to fix it. Make sure you have funding for remediation. Before you take off on this endeavor, make sure that the powers that be that are funding this operation also know that they may have to fund fixing the things that you find broken. And last but not least, make sure your incident response plan is sound and trusted. So I'll close with this slide and a thought. This is a question I ask a lot of times when I go in to talk to a company's security operations center. Excuse me, but what is it you're looking for? And the folks will typically tell me, I'm looking for the alerts and events out of the firewall and the IPS. I'm like, why? What is that? What is that going to tell you? Sometimes I'll get the really good answer. I'm looking for something suspicious. And that's actually a better answer. We'll address that in a minute. But I suggest most people focus on the easy stuff first. There's a lot that you can get out of the network. Again, if I don't take it out on a piece of paper or a thumb drive, your network's going to see it. So look for it. So what are we looking for? The first thing we have to do is define what suspicious looks like. Define suspicious and then go hunt it down. Some things that that are easy triggers for me and what's suspicious. Does data, where is data XXX and is it supposed to, where is it supposed to live in? Have you seen it anywhere else? Many times I've been on forensics investigations. A classic one, a retailer was popped. Their payment card data was compromised. They found out about it the same way 65% of companies find out that they've been compromised through a third party. They never detected it on their own. Actually, in this case, they found out about it by reading about it in the Sunday Times. Finding out that they and two other companies, the guy that did the hacking was going on trial, and their name showed up. That's how the CIO found out about it, not the way you want to get that news. At any rate, when I went in to do the investigation, they said, all of our PCI data is on server A, B, and C. I said, can I look for it? And lo and behold, it was on server Z and on a tower underneath the guy's desk. That guy happened to be a developer within their organization who was building some new software who needed some test data. Now, instead of obfuscating the account data, the username, and that kind of stuff, no, he took the raw, actual live database, copied it off, put it on his server for testing. So look for the critical data that you've got, understand the valuable stuff, figure out how you've got it contained, and go look for it being someplace else. Should that server ever communicate with anyone outside of this network? Unbelievable. Accounts payable system popped. I said, well, who should talk to this accounts payable? They said, people in accounts payable, maybe accounts receivable, general ledger. We've got these other applications. So the PC over in the mailroom, should it talk to this accounts payable system? No. Well, why didn't you do anything about that? Why did you allow this to happen? Exactly who should be accessing those data stores? If you've got a set number of people from specific addresses or on-net places that should be accessing some data, make sure that's the only place it's accessing it, and look for some kind of variance, like somebody in another country accessing it. Next, should that type of data be traversing your network? Fill in the blank. Look for keys like SSN would be a good one. Things that look like credit card information, is that moving around on your network? That's probably suspicious. Do you have a business partner in Iran? Again, look for VPNs. An easy way to tell. IceCamp and ESP packets, are they going out the door? That's probably an indicator as a VPN. If it's going to someplace that you don't have a business partner, go check that out. Should those comms really be encrypted? Another one of my key pet peeves is, in a hardened environment and a lot of corporate environments, I recommend don't allow encrypted communications off net unless you know who that partner is, unless there's a good reason for it. Yes, I know your users want to sit here at lunch and go to Bank of America and work with their account. That's not the purpose. Wait till they get home, deal with that. You don't need encrypted communications going off net because encrypted communications mean you can't see it and you don't know what's in there, and it could be your crown jewels. And lastly, is there a telnet session running on port 25? I love this one because it's an easy way to go prove something to a customer. You log into, you do a telnet session, or you actually do a telnet session, port 25 on the address of their mail server, log in, and then send somebody in that organization an email from themselves. It's a pretty easy technique, but it proves the point. The bottom line is there are tools out there to look for the actual protocol that's running inside that port. So make sure that the stuff that's inside that port is actually the protocol. It belongs in that port. Again, your network has a tremendous power of visibility into the environment, and once you start leveraging that visibility, you can also leverage that to perform control and help secure your data. Thanks.